So let's define a discrete geometry where every point has exactly two neighbors.
What do you mean by neighbor?
A neighbor is a point which is right next to it and which it can be connected to as part of the same line.
So if you have a point here and a point here, you said they are neighbors.
They're only
if
neighbors.
you have a point here and a point here, are they neighbors?
They may or may not be. So now it depends on whether you are allowed to draw a line through it or not.
Ah, I see. So if you do this,
And there's no point in between,
yeah,
then it's a neighbor. If this point doesn't exist. If there's a point in between, then these two are neighbors and these two are neighbors.
but is this a line? Line and the
No, not line, but that they can be connected.
oh, this means
Can be connected.
when this thing
Yeah.
means is
Connected.
connected to,
Yeah.
or this means is a
Neighbor of.
neighbor of. So that's what this is a relation.
Yeah.
Okay.
So every point has exactly two neighbors. What does this world look like?
Every point has exactly.
So say you take a point. Now this has two neighbors.
that is true.
Put it up. So now
Right.
this already has one neighbor.
Yeah.
So now you can just add another neighbor. This already has one neighbor, so you add another neighbor.
Can I also add a neighbor like this?
Yeah, that doesn't matter. And then this has one neighbor.
And what if I do this?
Now this one has three neighbors.
Oh, okay, so you can't do that.
Yeah.
Okay.
So what if you see what it's looking like is that it looks like one straight one chain.
yeah.
However, we require every point to have exactly two neighbors. So our only option here, so let's say we do this, our only option here is to connect these two.
Okay, so that looks like a garland made out of, or
Yeah.
necklace made out of beads.
Yeah.
Right? Every bead
Yeah.
has exactly two neighbors.
Yeah.
Like that.
So you can make this chain much longer, but it's fine. I mean,
Yeah. But if suppose I don't do that. So these two do not have two neighbors.
they have only one neighbor, and that's against.
So this is not. How
This
would
is
I
not.
get this kind of line then?
That now you would have to change the word. You would have to say every point apart from 2 points have exactly two neighbors.
Okay.
Has exactly.
So there are only 2 points that are allowed to have one neighbor each.
Yeah. So world 1 and world 2. Two neighbors apart from 2 points which have one neighbor. Okay. So this is an example of that world. If we connect this here, now this is the first world. This is world number 1. And if we remove that line, that connection, then this is world number 2.
Okay.
So
Okay. Depending upon how you set up the world,
yeah,
this will be allowed or not allowed.
yeah. So let's put these two worlds side by side. Let's keep it the same number of points. Okay.
So this is world 2
World 2 and
this is world 1.
yeah. So now, what's a straight line?
A straight line
In general,
in general is the straight line AB from point A to point B is the shortest path
From A to
A to B.
okay. So now, what is the straight line path between here and here? It's just these.
It's just these two. These are neighbors.
What about
yeah.
being here and here?
Suppose this is A and this is B. That's a straight line.
Then this, and this becomes the
Suppose you say this is D.
Yeah.
And D and A.
D to, let's put A there. All the way there. So what's the path?
That's
it's an entire chain.
It's a straight line.
It's a straight
so you just count the distance, you count the number of points.
Yeah. Now let's do the same here. What is the shortest path between D and A here? It's the same number of points.
It has to be this.
Yeah. So in this world, it's all the way around. In this world, it's just this. Right?
Okay.
The shortest path between here and here is this.
So supposing I said this is 1, 2, 3.
So the interesting one is the shortest path between this and this. So let's. What's the straight line path between these two?
Between
A and B.
A and B, you can go 1, 2, 3, 4. 1, 2, 3, 4. There are two shortest
There are
paths.
two short. So there's two straight lines between A and B.
Yeah.
So
either you can go either this way,
yeah,
or you can go this way.
Yeah. So if you may have seen in Euclidean, regular Euclidean geometry, people usually say there's only one straight line between. People say there's one straight line.
Exactly one straight line.
Exactly one straight line. Here that's not the case. In this one it is.
Yeah.
In this one it's not.
Okay. Okay. So these are very different words with very different theorems.
Very different theorems.
Very simple. Okay.
Yeah.
All that you have done is to simply add this clause.
Yeah. So let's look at one other thing. What's a circle?
Circle definition. Let me write the definition. A circle is the set of. Let me erase that. Set of all and only the points equidistant from a center.
Okay.
So if you have a circle and if you have a center here, if you take a point here,
The distance
and
from
if you take a point, the distance should be the same, no matter which point you take. And all those points should be included in the circle. That's a circle.
Yeah. So now, what is a circle here? So let's say we have a notion of length, right? The number of points.
Right.
So let's say what is the circle with center here, with center this point, with center O, and radius 1.
Radius 1. So here is one point, here is another point. Only those 2 points.
Only those 2 points.
So if you call it A and B, AB is those 2 points A and B will together form a circle.
Yeah.
That doesn't look like a circle.
It doesn't look like a circle, but it is.
I guess if you accept this definition,
Yeah.
that's
In fact, if you even just do on a, say your world is a Euclidean world, but only a straight line, not a plane, not a flat surface, but just a straight line. What's a circle here? Circle here is also just 2 points.
oh, okay. So if this is equidistant,
Yeah.
if A, CB, if you're bisecting it,
Yeah.
CB is equal to CA.
Yeah.
So this is not a surface.
This is where a Euclidean world, which is a flat, one-dimensional Euclidean.
One-dimensional world. So in a one-dimensional world, this is a circle.
Yeah.
These 2 points constitute a circle.
Yeah. So not just in, though this is true in discrete geometry, it's also true in Euclidean geometry.
Ah, okay. Okay, I didn't realize that. Okay.
So a circle with radius 1, 2, 3, with 3 will be these points, C and D, right? A circle with radius, what is a circle with radius 4? Centered in this one.
1, 2, 3. This will be 1. And 1, 2, 3, 4. Oh,
Yeah, so it only has one
only
point.
1 point.
Yeah.
Okay. 1 point is a circle
Yeah,
with center O.
yeah,
That's a very interesting result.
yeah,
You can't do that here in Euclidean geometry, right?
yeah,
Euclidean geometry cannot have 1 point as a circle.
yeah,
But in that geometry, yes.
yeah. And a separate center. 1 point as a circle and a center.
Yeah.
So
How about
which
here?
is not equal to that.
How about this geometry? This one.
Well, one more thing here. So in fact, by this, if you just move the center here, now this is a circle, just this point. So every point on its own is a circle in this geometry.
Every point is a circle? What does that mean?
Every point individually.
Oh, I see,
is a
because
circle.
there are two.
Because now you move the center
Right.
to this point, and now this becomes
Yes.
a circle.
Okay.
Just this.
Okay. So a circle with 4 units as the length,
Yeah.
as the
So
radius.
actually, we can write out all the possible circles. So one is each and every point, not a circle. Each point. Then each pair of points separated by at least one.
Okay.
In fact, separated by an odd number of points.
Yeah. Okay.
Each pair of points separated by an odd number.
Ah, okay. That should be it, right?
Yeah.
Can every closed loop have a point as a loop, as a point in a circle? So in this particular closed loop, every
Yeah.
point.
Yeah.
Okay.
This doesn't.
Okay, so you just added a point.
Yeah.
So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if the closed loop is an odd number of points,
Yeah.
then it cannot have a point
Then
in a
it
circle.
won't have a point in the circle.
That's interesting theorem from
Hmm.
that is true about this geometry.
Yeah. Now in this geometry it's a little more boring, right? So here it's only this and this are a circle, this and this are a circle, this and this are a circle, this and this are a circle. So any pair of points separated by an odd number
Odd
of
number of
points
points.
is a
But
circle.
you still cannot get a point
As a circle.
as a circle.
You can't.
Okay.
So this one's a little duller. This
Mhm.
is quite an interesting
Okay.
place to live in.
Hmm.